With this example, we need to identify the property that is being illustrated with each one of these. If you don't have a good understanding of each one of these properties, please check these out online. Make sure that you understand what the name of each one of the algebraic properties is and what it refers to. But we'll go through these together. So for example 1, we've got a number of some examples here, A through J, I believe. We'll start with the first one. And if we look at the structure of what's happening from the left side of the equal sign to the right side, we can see here that we're grouping the x times 9 together. And then on the right side, we're not grouping the x times 9. We're grouping the 9 times 2. So when I try to remember which property this is, I look at which parts are being associated together here. So the x and the 9 are being associated, and that association is being changed or being grouped differently. It turns out that this is true though. This would be x times 9 times 2 or 18x, and so would this. But if you're wondering which property it is, just look at here and know that the association between x and 9 is being changed, and so that'll give you a clue that this one should be the associative property. And part B, we've got 8 times 0 is equal to 0. I'm seeing a lot of zeros here. I'm seeing a number being multiplied by 0. So this might have something to do with 0. And if we look here, we're not adding 0 or dividing by 0 or subtracting 0. You're multiplying. So when we write this down, we could say this is the multiplicative property, and I'll abbreviate that for you, of 0. And that's, they don't really make these things up. I know it might seem difficult at first, but if you take a look at the structure of the equation, it can be a little bit easier to write down and remember what these are. You're multiplying by 0, so we call it the multiplicative property of 0. And that is basically that if you multiply anything by 0, you get 0. Part C here, you have negative 6 times y is equal to y times negative 6. So it looks like the negative 6 and the y are trading positions. This is not like the associative. The associative above is associating two, in this case, factors together, and then over here it's associating two different ones. That's not happening here. This is a little bit different. We've got negative 6 and y, and then they're being switched. For me, when I think about this property, I think about someone who has to commute to Chicago. Ooh, kind of a tough commute from the suburbs. Some people will commute 2 hours or more just there, and then another 2 hours or more on the way back. And so if you think about commuting, you're commuting to somewhere, and then you're reversing the trip back. So the reversing thing here is what clues me in that this is the commutative property. Little trick there with commuting. So the commutative property. It's when we switch places here. We switch places. Alright, so for D, we've got 9 times negative 1, and that equals negative 9. So we're multiplying here, and we're multiplying by negative 1. So you could call this perhaps the multiplicative property of negative 1, but oftentimes this is just stated as the property of negative 1. And that's it. Not too bad. 1 times v is equal to v. 1 times anything is equal to that same thing. And so this one, even though you might think it's the property of 1 or multiplicative property of 1, this is a special identity and a special property. Excuse me, I was leading into that a little bit. And this is the identity property. The identity property. So where you multiply something by 1, you get the same thing. It's kind of like you are who you are, and you are identical from the left and the right hand side. Nothing really has changed when you multiply by 1. If you look at the part D here, we multiply by negative 1, that 9 has changed. But here we multiply v by 1, and it's still v. It's identical. Alright, part F. This one, even though it's not multiplication, you'll notice the associations are changing. So this one will be the associative property. Just a few more here. I wish I could do these forever. That would be great. Math heaven. G 8.3 plus negative 8.3 is 0. And the one thing that we want to see here is addition and subtraction together. Addition and subtraction are known as inverse operations. Just like multiplication and division, they kind of undo each other. So if you started at 0 and you went up 8.3 and then you took away 8.3, you'd be back at 0. And that's kind of a understanding, a basic one of inverses. They kind of undo each other. So this will be the inverse property on this one. Part H, we see that we're going negative. We've got negative y and then positive 0.7, and then those are switching places or reversing. And so when I think of this, I think of that awful commute down to Chicago, or perhaps whatever city, that big city that you live close to. So this is the commutative property of algebra. And we've got the 3 plus 4 and then 4 plus 3. Same thing as this one. They're just reversing. Tricky. Oftentimes you don't think you could have two things in a row that are the same, but this one is commutative. J, 4 times 1 over 4 is equal to 1. Even though this is multiplication, when we do 4 times 1 we get 4, and then we're dividing here by 4, and these essentially here are inverses of each other. If you think about it, if you started at 1 and you multiplied by 4, you get 4, and then if you multiply by a quarter, you get back to 1. And so this operation here, this is an undoing operation. So from 4 we could divide, or we could multiply by 1 over 4, and that would get us to 1. And that works with any number. So if you have 8, you could do 8 times 1 over 8, and that would get you right back to 1. So this one is going to be the old inverse property. I think we saw that before, but with addition and subtraction.